Hi everyone, and you are welcome to Introduction to OOP lecture. Before I start, let me ask you, are you wondering why I have to learn OOP? So if the answer is yes, let me tell you that this lecture is going to answer exactly this question. So let's get started. First of all, I'll start talking about what we have before OOP in order to understand what OOP is and why we need object-oriented programming. After that, I'll highlight the most important OOP advantages, and I'll end up this lecture by a quick summary. So what we have before OOP? Actually, in the past, when the programming languages appeared, they supported what we call primitive data types or simple data types, like integer, float, or boolean, etc. There are other types. These types actually are very good for simple programs, like the following, if I want to add one number to another. And these data types are good for any arithmetic operations. However, nowadays, we have more complex problems that require more complex software. But these data types are very limited and can't represent complex word objects like car, employee, bank account, etc. And as we know, these entities are very common in the modern software. Therefore, it's clear that the old programming languages suffered from an issue about how to define and handle new and complex data types. And in order to handle the previously mentioned issue, OOP has come to the scene. So what's OOP? Simply, OOP is just a programming style throughout the developers are able to create new data types by binding together two things: the data properties that describe the new types and the functions that process these properties. In other words, OOP provides the developers with the flexibility to create new types by combining together the data and the functions that handle these data. In context of OOP, we call the new data type that we want to create a class. And we call the data properties that are related to this type attributes. Also, we call the functions that handle these properties methods. And these three words are very common and you will see them a lot in this course. Now, in order to make the idea clearer, let me share an example with you. Assume that I want to build a software to handle transactions inside a bank. The most important data type in this case is bank account. So let's see together how we can create a new data type for a bank account. Simply, it's the following. First of all, I'll give this data type a name, and in this case, it's just a bank account. After that, I'll define the properties that describe this new data type, and in this case, we have account holder name, for example, account ID, and the balance in this bank account. After that, we have to define the actions that I can do in order to process these attributes. So for example, when I have a bank account, I can withdraw money, which means I can take some money from my account, or I can deposit money. I can add some money to my account. So in this case, bank account is the class, account holder name, account ID, balance are the attributes, withdraw and deposits are the methods. So far, we just have defined the new data type, which is a bank account. But how to use this bank account? Simply, you have to define an instance from this bank account. And in this context, we call the instance an object. Like for example, when we have integer data type, we define an instance from integer just by assigning an integer number to a variable. And here we are doing the same thing. But here, when we define an instance or an object from a class, we have to specify values for the attributes that these data types has. So for example, for account holder name, when I define an object, I'll say John Smith, which is actual value for this attribute. Also for account ID, I'll give an ID, and the balance in this case, I assume just 200,000. Once I have an object from this data type, now I can use actions on this data type. For example, I can withdraw some money from my account, or I can deposit some money into my account. And in this case, I have to use the methods or the function withdraw and deposit. Now, let's talk why OOP is very important and why you have to start using OOP from today. First of all, as we see, OOP style focuses on creating reusable patterns of code, because in OOP we are creating our data types one time and then we are using these data types again and again. And this will help you to save a lot of time because you are reusing the same codes. Also, because your code becomes reusable, you need to write less lines of codes in order to solve a problem. And this will make your total code easy to be maintained. In addition to that, OOP allows us to represent real-life concepts easily and smoothly in computer programs. Therefore, OOP makes the process of translation of our problems into software solutions easy and straightforward. And if you combine all of these advantages together, you will see that your productivity as a developer will increase very much over the time. That's all for this lecture, and now let's summarize what we have learned. First of all, we see that old programming languages supported primitive data types, and these data types are very limited and insufficient to solve complex real-world problems. And for this reason, OOP has come to the scene, and it's a very good solution for the previously mentioned problem because it allows us to create complex data type by combining together the data properties that describe these data types and the functions or the methods that handle these data types. After that, we see that we call the data type that's created in OOP a class, and we see an example about a bank account. To this bank account, we add some attributes, some methods, and once our class is ready, we are able to create an actual instance from this class, and we call this instance an object. At the end, we have talked about OOP advantages, and we see as a summary, OOP improves developer productivity because it helps create reusable and maintainable patterns of code. Thank you very much for your time, and if you are available, join me in the next lecture.